Today's lesson is 5-2, finding equations of inverses algebraically. So yesterday we looked at inverses via a table and graph. Today, given an equation representation, I can represent the inverse function as an equation. So from lesson 5-1, what have you learned about inverses so far? So far we know that it's just x and y values switched. So if we were given f of x, we know we have the coordinate x, y. So that means our inverse, the coordinates would be y, x. Whether we're given a graph or a table, all we're doing is switching our x and y coordinates because we're reflecting over the line y equals x. So we're going to use this concept with inverses and switching x and y's to be able to write equations of our original functions. So we're going to start off with an equation of a line. So it says find the inverse of the function below. So we're given f of x equals 3x minus 1. Well, we know that f of x is our y values, our outputs, where x is our input. So if we were to rewrite this as y equals 3x minus 1, we now have a y and an x value. Well, if we're trying to find the inverse, we know that the inverse is y x. So we need to switch our y and our x value. So if I take my y and my x and I switch them, then I'm going to be able to solve to find the equation of my inverse. So when I switch x and y, I have x equals 3y minus 1. Well, if I'm writing an equation, I need y equals. So I'm going to solve using inverses to find what y equals. So my goal here now is to solve for y. So to solve for y, I need to move over my minus 1. So I have x plus 1 equals 3y. And to get y by itself, opposite of multiplication, or the inverse of multiplication, is going to be division. So I'm going to divide by 3. So I get y is equal to x plus 1 divided by 3. So if I started off with f of x equals 3x minus 1, and I switched my x and y coordinate, now I have the equation of my inverse. So my inverse is going to be x plus 1 divided by 3. So you can see we're switching x and y and then solving for y to get the equation of our inverse. So example number 2 says find the inverse of this function and then confirm by graphing both on your calculator. So you're going to want to have your graphing calculator out. So if we want to find the inverse, well, we have y and x, so to find our inverse, we have to switch. So if I were to rewrite this, I would have x is equal to 27y cubed. Now I need to solve for y. So right now I have 27 times y cubed. So if I want to move over 27, I have to do the inverse, which is dividing by 27. So now I have x divided by 27 equals y cubed. Well, if we remember back to our radical unit, in order to get rid of a square root, I took the in order to get rid of a square, I took the square root of both sides. So in order to get rid of something cubed, I need to take the cube root of both sides. So I'm going to take the cubed root, I just have an index of 3, out in front of both sides. So the cube root and the cube go away, and I'm left with y. And then if I take the cube root of x and the cube root of 27, I have the cube root of x over 3, because the cube root of 27 is 3. So now this would be my inverse. Y equals the cube root of x divided by 3. So if I want to confirm by graphing on my graphing calculator, I would type in my original function into y1, my inverse into y2, and then on my graph I should see that over the line y equals x, my points are reflected. So something else that would be very good to look at would be our table. So if I were to make a table for my original function and a table for my inverse, I should see that when looking at my graphing calculator, my points are switched. So you could look at your x values, copy down your y values from y1, and then you would see that your x values and your y values from y2 are just your original function, but switched. And example 3, it says find the inverse of the function below and define any domain restrictions on the inverse and confirm by graphing both on your calculator. Now, we're going to find our inverse first, but then thinking about domain restrictions, remember back on our radical unit when we had radicals and rationals, how we had extraneous solutions. Now we're going to have to think about why a radical would have domain restrictions when we're looking at inverses. So we're going to start by taking the equation and writing its inverse. So we have f of x equals square root of x plus 7 plus 3. So right now I have y is equal to the square root of x plus 7 plus 3. So if I take y and x and I switch them, that's the start for writing my inverse equation. So I have x is equal to the square root of y plus 7 plus 3. So my goal is to solve for y. So my first step is I have to move this plus 3. So to move plus 3, I have to do its inverse and subtract 3 on both sides. So I have x minus 3 is equal to the square root of y plus 7. Now we have to get rid of our square root, and we know that the inverse of a square root is to square both sides. So I'm going to square both sides. When I do that, I have x minus 3 squared equals y plus 7. So my last and final step to get y by itself is to subtract 7 on both sides. So that means that my inverse is going to be x minus 3 squared minus 7. So I have my function and I have my inverse. So if I were to graph both of these, I know that when I graph a radical, I should have something of this shape. But I look at my inverse, and my inverse is a parabola, something of this shape. Now these two don't match up exactly. So what I have to look at are my domain restrictions. So what I want to do is I want to graph my original function, and I want to figure out what my domain and range are of this. So go ahead and graph your original function, and I will graph as well. So you can see here that I have graphed our radical, root of x plus 7, our inverse, 3, which we have a parabola, I can see that, and then our line of reflection, which is y equals x. So I have my starting point. Right here, our blue line is f of x negative 7, 3. Red is going to be our inverse. So my function, I have a domain, and then we have our black line of here, my x value starts at our line of reflection, and it's anything greater. So we can see that when we reflect, my range, my y values start at 3 over our line of reflection. So y has to be greater. We're going to be on this side, equal to 3 of our parabola. So that means, means this side is not actually a part of the inverse. That we have this domain restriction that on our inverse function. Should be my x values have to be greater than or equal. If we switch our x and our y's, we're switching our domain and our range as well. So if we look at our original function and we state our domain and range, so when our domain is all x values, we're at negative 7 or greater. So x has to be greater than or equal to negative 7. Where our y values start at 3 and are greater. So our range is our y values have to be greater than or equal to 3. So if this is the domain and range of our function, this is what our domain restriction is. Now, we need to put a domain restriction on our inverse, and if our inverse is our x and y switch, it's the opposite of the domain and range of our function. So our domain would have to be that x has to be greater than or equal to 3, and then the range would be that y has to be greater than or equal to negative 7. So we can see that where we're reflected over, these values are all greater than 3. So this is our domain restriction. So we have our inverse, which we stated was x minus 3 squared minus 7. So this is our inverse, but it's only when x is greater than or equal to 3. So this would be our entire answer, is that this is our inverse, but it's only when x is greater than or equal to 3, because those are the only points that we have reflected over our line of reflection.